Morning, it's Martin from Martin's Engine Services. Well, it's Friday morning. It's a beautiful day. Sun's breaking through. Very autumnal morning, a little bit misty, but it's going to be another glorious day. Anyhow, I'm recovering from the plague, which I got. I mean, it clearly wasn't a cold because men don't get colds. It was obviously the plague or something similar. But I've heroically soldiered through. So we're feeling a lot better today. I still got a few jobs done yesterday, fiddled around and whatnot. Anyhow, what I'm going to do today, I don't really fancy doing any welding today. The trailer's just sitting there idling its time away, but I'm not really in the mood for welding. So I thought we'd do a bit of machining. And today's conundrum, and this really is a conundrum, I need to mount a flywheel onto here, and I've got a crankshaft pulley from Peugeot Citroen diesel engine. What I've got to do, this is the original boss that was attached, had the blade attached. This actually had a steel disc welded to this, and then the blade bolted to it. Now this is a nice fit onto the crankshaft. There's no play in there, it sits nice. What I need to do is turn the outside of this down to fit inside the pulley. And I'll put the pulley on, not all the way on. I'll leave the pulley overhanging by about 1 millimetre. And then the washer and bolt holds this on, will keep everything clamped in place. Now the problem is the outside of this piece of metal at one point was obviously machined. However, it's got pitted with corrosion from grass and mud. And although I've cleaned it up, it's not completely round. So when I mount it in the lathe, it unfortunately is doing this. Now if you flip it over, it does the same. So I need to make sure that the inside machine surface of this remains parallel to the outside at all times. So I spent some time pondering how to get round this, and I tried a couple of different techniques to make sure it sat squarely in the chuck. Now obviously one technique is obviously put it in the chuck, spin it, move it, fiddle around with it, and sometimes you'll get them to true up. I mean, a 3-jaw concentric chuck is usually pretty accurate, but to be 100% you need a 4-jaw chuck. Now I don't possess a four door, Martin's off again, a 4-jaw chuck that's quite big enough for that job. And I'm not really in the mood for spending hours trying to get it set up. Now, you can sometimes grab them on the inside, but none of my chucks are small enough to do that. So I thought, I've tried another trick of putting it in the jaws loosely, then bringing the centre up, and then pushing against the chuck with the centre to centralise it, then tightening it up, but it's still not running true. So what I think I'm going to have to do, well, before that I have checked that the chuck is running concentric. I have a test bar, an accurately ground test bar for setting the machine up. I've put that in here, and that's about that long, and it runs perfect. Wherever you put it in, do it up, it runs true. So I know that the chuck is running true to the machine. The centre point goes straight up the end of the test bar, so we know everything is parallel. So what I think I'm going to have to do is use a piece of spare steel, machine this down till it actually... I just grabbed this out the metal box last night before I knocked off. Machine that down so it's an accurate fit onto here. I'll obviously have to drill and tap the end and put a pinch bolt in to hold this. Then I'll machine this down, put this over the top, bolt it on, mark its position so if I do have to take it off I know where it come from, then machine this down to go through this pulley. Now this pulley here, let me think, oh yeah, I put this bolt in to lock it onto a stationary engine because this diameter here is exactly the same size as the crankshaft on a Lister and Petter petrol engine. So that's handy. So this I know is an accurate bore, so I need to put this through like that, or partly through. So well, obviously once I've got this in the chuck and I've machined this true, I can't take this out of the chuck for fear of moving it. So any operation, this must stay in the chuck. If necessary, I'll just transfer the chuck from machine to machine, which usually works out okay. So that's what I'm going to be doing. So I'll bring you along. I lost the chuck key. This is the thing that will disappear more than anything else when you're doing machine work or drilling, the chuck key. Where does it go? Nobody knows. So we'll put it there, and in 3 minutes time it'll be gone. So that's what I'm going to do. First of all, I'm going to set this up. I'm going to drill the end. I'm going to thread it. Then I'm going to very carefully machine the outside down so that boss just goes over there. Pretty good tight fit. And then I can work from that. So as long as I leave that in here, we'll be okay. You can only screw up in one place. So that should be it. So I'll set up, and then I'll bring you along for a few of the processes. Right, now first of all, I'm just going to center drill it. Important thing, oil. I don't think this is the world's best center drill, but it'll get there. That'll do to start with. So it doesn't have to be 100% accurately thread, because it's literally just going to be a draw bolt, or just hold it in place. It doesn't really matter totally. You see there, I don't know if you can really see that, but there is a slight swing out on this. Because obviously this bit here has been machined already, and this is rough finished steel stock. So whatever machine it was machined in before, you get a variation. I have actually marked the chuck and the work here with a white line. So if I have to take it out, theoretically it'll go back in the right place, but that's no guarantee. I mean, it is something you don't want to do unless you actually have to. So what next stage of operation is to start drilling that. So get the drill out, drill hole up the inside, and you're feeling strong to do that up. Right. Right, well, I've drilled a pilot hole. I think it was about 3 mil. No particular reason, just 3 mil was the first drill I picked up. I'm now going to drill it 7, which should be fine for threading it out M8. Proper size really is about 7.2, I suppose. But the natural tendency is for it always to slightly drill over, so what I want, that'll be fine. I'm just using engine oil as cutting oil, because the cutting oil's not to hand and it means walking, so it works fine. Very nice piece of steel this, actually. It's a good quality bit. No need to hang on there when you're cutting, just let the drill do the work. No need to heave the thing round and be brutal with it. It doesn't help. All you do is overheat the drill bit and run the risk of breaking it. So that's reached the bottom now of the pilot hole. He's quite happy to go straight through at 7 there, so right. The tailstock clamp on this does actually slide a little bit. It locks underneath the bed, and it's a bit worn in certain places where obviously the machine's done all its work. And there's an adjustment nut, so sometimes you have to just sort of adjust it a little bit. I mean, you've got to imagine this machine was made in 1942, and as I mentioned in the previous video, when I rescued it, this poor thing was absolutely, well, basically it was scrap. And it's the fact that it's come back to life and is still remarkably accurate is a testament to how well these machines were made. And there are a few bits I never did finish. Could do with a new peg in the tailstock there. There's a peg there that controls the rotation of the shaft, but one of them getting round to it jobs, a bit of maintenance. But no, it's still very good considering. Oh dear, we're hanging in there. Right, next thing I do is just thread that M8, so I'll get that sorted out and then I'll bring things back. Now, nice and easy to start the tap off like this. Mount it in the chuck, release the belt tension so you can just turn the machine manually, and then just don't clamp the tailstock as such, just gentle pressure. You can just work your way in with the tap. Unfortunately, if the tap's getting too tight, it will just spin in the chuck, so there's no fear of breaking it. Just gently do that, and you will now start the thread off nice and square. Right, that started by about a turn and a half, so now I'll just use leave the tap in there, slide the tailstock out of the way, and I'll get an adapter to go on there. And then we just thread it in conventionally, and then we've got the thread where we need it, and then I'll start the process of machining it down. Oops. Now these are a handy little set of tools I bought years and years ago from my Snap-on guy. They look like sockets. Basically they got squares inside which happen to fit onto the end of taps. Now they're 1/4 or 3/8 drive. The brilliance of it, of course, is you can simply use any conventional ratchet type square drive on them. Now when we do like exhaust manifolds and stuff, brilliant, because you could get a tap on an extension up the manifold or whatever. Brilliant. These really have been a truly incredible asset. And it's just a question now of doing the usual cut the bit, clear the tap procedure. I think actually I'm just going to have to open it up a fraction more. That's cutting a bit tight. I'll go and get a 7.2 drill, do it properly mine, because you know what's going to happen next. Mine's going to snap the tap off in there. Right, that's sorted that out. I went 7.5 in the end. It's a fraction over, but that'll do. There we go. That screws in there nicely. Okay. Now, the amount of tools you end up with out for simple operations is crazy sometimes. Anyhow, now we're going to do is get set up to machine this. A bit of messing around, got to switch the tool holder around and bits and pieces. Because if I've got to machine the axle again, I've got to flip everything back again, but not a problem. Never mind. This was a component that was broken on this machine when I got it. This part of the casting had been snapped off. And what my dad actually did is he made a new part here. And you see these bolts. These bolts here are actually so drilled and tapped into the main casting. And I think there's a couple of hidden pins the other side. And with some engineering adhesive, this section was then bolted on into place. So there we go about that. A clever solution to a major problem. And then it was obviously just decked flat, and that's it. You have to find ways around mending some of these sort of things when they're like that. And obviously, some of them are, you know, myford lathes like the ML7s and the ML4s and bits and pieces. Like I've got an ML4. You find parts for people breaking up machines, etc., etc. But this one you will find no parts for. I do look from time to time on Facebook and eBay and other search places, but they never come up. There was actually another one of these for sale, complete, a few years ago. I think it was the 26-inch bed version or 24-inch, and the guy had advertised it's not knowing what it was, so I put him in touch with the guy who knows about these, or most machine tools, and he was able to find us more info on it. But it was a complete machine. It actually had the proper chip tray, because when I made this tray for mine, the chip tray was missing, I made this. He had a few of the other bits and pieces, so it was nice to see another one. But in the 12 odd years I've owned this, only one more has ever come up for sale. So it can be a, let me get this right, it can be an ML54, an mf54, or an ML74, also known as the 3.5-inch precision. And it had a couple of other names. It was a bit of an oddity that myfords made back in the day. As I said previously, they made under 500 of them, and they only made it, I think, 1942, 43. That was about it. There was a pre-production version that actually had Jones and Shipperman on it, which is another great machine maker, and a few other bits. But they are a very, very rare machine and are very much an oddity. So it's a lovely old machine. It's done, as I said, it was completely wrecked, but it's still working well. So what more can you ask of a machine? So what I'm going to do now, I'm going to get set up to, oh, there goes the camera. Put a centre in there. This centre's got a ball race mechanism inside, so it spins all the time. And that will just help support the end of the work. Because there's always a tendency as you're machining, as the tool comes into place, for the work to naturally climb slightly. And you will get slight movement in these bearings because they're only plain bearings, and you can get the tendency for it just to move and just not be 100% accurate. I mean, you've got to make allowances for the age of everything and whatnot, and the fact that I'm not the best at times. Right, let's get this in position. Just nip that up on there and make sure it's all running true. Tighten the belt up on the counter shaft. That's better, Martin. That looks lovely. Then I've got to do is now set up a machine, set up a tool, bearing in mind I've only got that much travel, and then start turning that down as accurately as possible. So I've got to find a decent tool, get that set up, and then we shall proceed. Right, well there we go. We're just starting to rough it out a bit now. I've got my favourite old tool on here. It's I don't actually see this, but it's actually got a bit snapped out the corner of it. It's an old tungsten tool. It's got broken, and the remaining bit is one of those magic lathe tools that you can use for anything. It's one of those ones that's sort of like your favourite tool. It does a pretty good number at shifting metal fairly quickly. Now this bit of steel's actually got in it, about here, quite a hard bit. See, that's machining beautiful now. It's taking a nice volume of metal off, nice and consistently. Now as I come back along, you'll hear the note change. Right about here. And it's a real hard nugget, and I've been having trouble getting through it. So that's fine, and then I'll start to hit it soon. You're right there. Right, let's have a look. Going to make sure it's obviously deep enough for the job. So just get the vernier, measure the depth inside that, transfer it to there, and we need to, well actually it won't hurt, no, hang on, think Martin. Do I want it up against the face? No, I'll have it up against the shoulder actually to be safer. I'll actually machine a stop solder. Martin's off again. Shoulder. I'll machine it to a stop and then just shorten the end so it sits against the machine shoulder on there. Although I am presuming, of course, that this is flat. Right, okay. No, better off making that longer so it sits. I'll face that up, make sure it sits against that. Then I know I'm safe. Let's not introduce any more variables. So we need to take a bit more off of that. So you can hear that hard again there, that's got that hard lump in it again, that's what I encountered earlier. You see the change in colour on the surface of the steel as well. It looks on camera like I've got my finger right against the work, but in reality I'm that far away. No, don't stick your fingers in the machine while it's working, people, please. People go, oh, that looks good. Whoa. You think a lot of these machines were made before safety existed. This one's not too bad because all the belts and everything are down the back there. Again, it looks like my finger's on the belt, but I'm actually 5 inches away. Anyhow, that's the process. I won't bore you with the probably half an hour messing around with that. I'll get it somewhere close and then I'll bring you back when we're nearly there. Right, we've got it down to size. It's just a fraction now. It just goes on there. It just literally needs a little bit of polishing. So I'm just going to polish a little bit off. Tried and trusted method. Hold this lightly, so if it does catch, it just pulls out your fingers. Oh, excuse me. And that's the remaining 2 brain cells gone, so normal service will be resumed. That. That's lovely. Excuse me. I might even actually leave that fractionally tight. Just pull it on there, then I can press it off afterwards so I know there's no chance it's going to move. So, oh, how close is that? And just see where it's galling a little bit. Let's just take a little bit more. Definitely don't want to try and machine any more off because that definitely will be fatal. The actual size of the hole inside the bit of metal is 22.25, and this at the moment is 22.2627. Yeah, there we go. Bit of oil and we should be there. it's close. That's so close. Whoops, just noticed that the radio on in the background. So hopefully no one heard that. So if you did, please ignore it. Yeah, that's just so close. Let's just take a tiny bit more. Then I think we'll call that it. This is the bit where it's very tempting to think, oh, I'll take a tiny cut off that. And you just take a tiny dust cut off it and bam, it's too small. Learned that lesson. The hard way. Yeah, I think that's what I'll do. I think I'll just tap that on there. Then I know it's a good tight fit, and I can always press it off. That's no problem, because there'll obviously be a hole here. I can support that in the press, and I'll just press it off. So I'll tap that on, get the bolt set up, and then it's time to machine the outside. Well, there we are. She's all on there. I did have to resort to taking just a fraction more off the shaft, polishing a bit further, because it got halfway on fine, then it got stuck. So I had to resort to using the puller to get it back off again. Just put the bolt in the end and pulled it off. But I think we safely say it's very accurate. It's gone in there nicely. And it now runs. Yeah, that runs nicely now. You just see there's a slight, you can't really see it, but there's a slight oscillation on the outside. And say the surface is pretty rusty and a bit gaudy. So now we can turn down the outside. I suppose what I ought to do is put a centre point in that bolt actually to be on the safe side. Right, now we've got a centre point in there. So it's just a question now, machining the outside this down to size, and I'll then fit the pulley on while it's still in the machine, clamp the pulley up, and if there's any run out in the pulley, I'll just tidy that up as well. So it should all be theoretically. Now Martin's made up more fantastic words. Theoretically. Let's try theoretically. Another big word for the motor trade. Must be all this precision engineering and thinking that's creating all this. Nah, let's not go there. I know this is quite a drawn out process and there's quite a lot of flapping around just to mount that onto a stationary engine and whatnot, but it's very satisfying to do this sort of thing. That's 30, we're going to go to 30 mil. So we've got to take a fair old chunk off that, almost down to that sort of size. Right, so we don't want to go full depth because we want the clamping effect to be the washer on here, so the whole lot is held up against the shoulder. There's a nicely machined shoulder in the factory pulley here, so some calculation is necessary. Right, the quickest way to do that is to put that on the lathe bed. Can't see me do that. Put it on the lathe bed, measure down to the shoulder, and that gives you your depth of cut. It's about there. So using the scientific principle of draw a line, chop a bit off to about there or thereabouts, that should do the job. So I'll start reducing that. If anybody says, oh, could you just machine this for me? Reality is it's probably 2 or 3 hours work, but I like doing this sort of thing. Keeps me amused, keeps the old grey cells working. So I'll start reducing that and then I'll bring you along when we get somewhere near to it, sort of maybe fitting-ish. Well, we're doing well. It's nearly there. It goes on alright, it's just a little tight up by the shoulder, so I've just got to take a tiny little bit more out just at this very end here. And very slightly undercut that. So as it goes along, it just drops down a fraction. Voila. Now, we need to find the nut and the washer, see how it runs. It would appear that there is a very slight variation in this pulley. Seems to be very fractionally larger than the damage on the yeah, well, they've made it. There is a slight taper. Oh, okay. Oh, well. Ah, okay. I just wonder where this washer's just come from. It would appear that there is a... where they welded the plate on the end of that collar, that must be the... Okay, well, alright then. Maybe we don't need that bit. No, I don't need that bit actually. Yes, I do. I do need that in there because I need the whole lot to squash up. Yeah, what I'm going to need to do then is slightly move the pulley slightly back. Slight redesign, folks. Nothing too serious. Move the pulley back a bit further on there. Anyhow, that's the basics of it. So before it turns into 1 hour special on Martin making bits of swarf everywhere, I'm just going to move the shoulder back about 5mm, and then that should all work out okay. So I think I'll call that it on that one, for it gets we're up to 33 minutes already, and you've probably fallen asleep watching me turning bits of metal, but hope you found something interesting in a bit of basic engineering, well, as basic as I do it. I know anybody watching who's a professional engineer or does lathe turning for a living will go, oh, what's this lunatic doing? But I make the best job I can with the equipment I've got, and basically have a good go. So it's always got me through in the past. So I hope you've enjoyed this little video. Please like and subscribe. Any thoughts, or feel free to have a laugh at what I've done. I'll be always interested to hear what you think. So we'll leave it there, and bye for now.